I am Anil Kumar. Welcome to my series on partial fractions decomposition. We are talking about rational functions. In this video, we will discuss how to decompose rational functions when linear factors are involved. We could have repeated linear factors, and we could also have a situation where the degree of numerator is higher, as in the last two examples, right? So these are different examples which we will consider one by one. So the idea here is that any rational function r of x is written as ratio of polynomials, numerator over denominator, right? Where the denominator is not equal to 0 and both n of x and d of x are polynomials. So we need to know simple factoring techniques to solve such questions. Let us see how to write them as partial fractions one by one. The very first example is ratio of two linear factors. So we have x minus 3 over x plus 7, right? Now we could write the numerator as x plus 7. Now we need minus 3. So we could do minus 10 over x plus 7. Now, this is a very neat technique to decompose fast. So we can now write this as x plus 7 over x plus 7 minus 10 over x plus 7. So clearly x plus 7 over x plus 7 is equal to 1 minus 10 over x plus 7 is our result, right? So we have decomposed this into two partial fractions. One is also a fraction, 1 over 1 minus 10 over x plus 7. Now in such cases, you could also do long division, right? Let me show you that also. So if I do long division, dividing x minus 3 by x plus 7, it goes one time x minus 7. Remainder here is 1, right? Remainder here is minus 10. So see, from here you can again get the same result straight away. So whenever the denominator and numerator degrees are same or the numerator degree is higher, first step is to divide. Then you get like a mixed number, right? So if it is kind of an improper fraction, you could actually divide and then get this kind of a result, right? So that is the rational functions. We are involving polynomials, so it is called rational functions. So I hope this step is clear. Now this could be a very simple example. However, most of the time we are actually working with such simple rational functions to decompose. So you should be master at it. Now let's take up slightly more complicated cases. Now we have 1 over x squared minus 2x minus 3. Since the denominator is not factored, we need to factor this. So I could write this as 1 over product of minus 3, sum of minus 2. So x minus 3 times x plus 2 can work. Now this rational function could be written as combination of a over x minus 3 plus b over x plus 2. That is partial fractions decomposition, right? That's the whole idea. Now, if I multiply both sides by x minus 3 times x plus 2, what do I get? So if I multiply both sides by x minus 3 and x plus 2, on the left side, I get just 1, right? So I get 1 equal to a times x plus 2 plus b times x minus 3. Do you see that? So, or you can say, you can take a common denominator and then cross multiply. That is what we get. Now, this is basically, you see x terms, we may write like this, ax plus 2a plus bx minus 3b. Taking x as a common factor, we get here x is a plus b and the constant terms is 2a minus 3b. Correct? So that becomes the constant term. All this is equal to 1. Now if you compare left side with the right side, coefficient of x should be 0. So that gives us two equations to work with. So the first equation is that a plus b is equal to 0. And from here we can say a equals to minus b, right? The second equation which we get here is 2a minus 3b should be equal to 1, right? Since the constant on the left side is 1. Now we know a is minus b. Substituting a as minus b here, we get minus 2b minus 3b equals to 1. Correct? And this will give us minus 5b equals to 1, or b is equal to minus 1 over 5. Since we know a is minus b, we can write now a equals to 1 over 5. Does it make sense to you? So we get the values of a and b. That's the whole idea. And therefore, we can write down that the rational function 1 over x square minus 2x minus 3 should be equal to, a is 1 over 5. So it is 1 over 5 times, look into this, x minus 3. And b is minus 1 over 5, minus 1 over 5 times x plus 2. Is that clear to you? So that is how we could do partial fractions decomposition when we have linear factors, right? Let's take up another example. Now in this example, we have factored form in the denominator, numerator is 2x minus 1. So again, whenever there is a linear factor in the denominator, numerator can be only a constant, right? So remember this. So this could be written as a constant over x plus 1 plus b over 3x plus 2. Now if you cross multiply, you can do like this also. A times 3x plus 2 plus b times x plus 1 should be equal to 2x minus 1. Clear? So we multiplied both sides by x plus 1 times 3x plus 2. Right? Now if you compare, what do you get? So a is getting multiplied with 3x and b is multiplied with x. So as far as x is concerned, we get 3a, and from here we get b. The constant terms are 2a plus b. Do you see that? 2a plus b. Now that gives you again two equations. So let's write down the equations and solve them on the left side here. Comparing the coefficients, we get 2 is equal to 3a plus b. And the other one, minus 1 equals to 2a plus b. So these are the two equations which we get. Equation 1 and equation 2, correct? The idea is to find the values of a and b. Best thing to do in this case is to do elimination. We'll do equation 1 minus equation 2. So equation 1 minus equation 2 will give us what? 2 minus 1 minus 1 will be 3, right? 3a minus 2a is a, and b minus b is 0. So we get the value of a, right? So what we get here is equation 3, which is a equals to 3. Now we can substitute the value of a in 2 and find b, correct? So we can now substitute a equals to 3 in equation 2, right? So when you do that, you get minus 1 equals to 2 times 3 plus b, right? So it is minus 1, and this is 6 minus 6 equals to b, and that gives you the value of b as minus 7, right? So we get the value of b as minus 7. Now we know a and b, and therefore we could write down our result. A is 3, so it is 3 over x plus 1, and b is minus 7. We get minus 7 over 3x plus 2. Is that clear? So that is how we could do partial fractions decomposition. Let's take up example number 4 now. Now in example number 4, we have repeated linear factor in the denominator, right? So that is the difference. So in this case, we'll write this as sum of 3 factors. One is 1a over x plus 1, the first factor, plus b over x minus 2, plus c over x minus 2 whole square, right? So effectively, there are 3 factors here, right? So that is how we get these different types of factors. Now, to get our result, we'll again equate x minus 1, 2. We'll multiply a by this denominator, which is x minus 2 whole square, plus b times x plus 1 times x minus 2, right? Plus c times x plus 1, correct? So let's expand this. We get a times x square minus 4x plus 4. Here we get plus b times x square minus 2x plus x minus 2 plus c times x plus 1. Clear? Now we can combine the terms to get x and y together, right? So let me go one more step. We'll write x square first, and we get a from here. In this case, we get plus b. Here we do not have x squared term. Now let's look for x terms. As far as first a is concerned, minus 4a. Minus 2x plus x is minus x, so we get minus b here, and here we get plus c. Now the constants, we get 4a minus 2b plus c. So that becomes the constant. So that gives you 3 equations, correct? So now we'll write down our 3 equations and then solve. The first equation is a plus b equals to coefficient of x square is 0, right? So that is the first equation. Well, from here you can write a equals to minus b, right? Okay, so that becomes one set of equation for us. We'll call this as our equation number 1. The second equation here is x coefficient is 1, so we get minus 4a minus b plus c equals to coefficient of x, which is 1. Here, if I substitute minus b here, I get 4b, right? Substituting minus b for a, we get 4b minus b plus c equals to 1. Or we get 3b plus c equals to 1, correct? So we'll call this as our equation number 2. Third equation is comparing the constants. 4a minus 2b plus c is equal to minus 1. So we can substitute 4a with minus, we get minus 4b minus 2b plus c equals to minus 1. That gives us minus 6b plus c equals to minus 1. So we have now equation number 2 and equation number 3. With these 2 equations, we can eliminate c, right? So let's do that. So what we will do now is we will do equation 2, take away equation 3. Is that clear? So when you do 3b minus 6b, we get 9b here. C minus c is 0, and 1 minus minus 1 is 2, right? So we get here 2. So that gives us b as equals to 2 over 9, right? So we get b as 2 over 9. We'll call this as our equation 4, which is one of our result. Since we get b as 2 over 9, we now know that a is negative b should be minus 2 over 9. So we'll call this as our equation 5. To get the value of c, we can get it from either one of these equations. We can say from here c is equals to 1 minus 3b, right? So which is 1 minus, b is 2 over 9, so 3 times 2 over 9, right? Which is 1 minus 6 over 9, or 9 minus 6 over 9, or 3 over 9 or just 1 over 3, correct? So we get the value of C as 1 over 3. So we have all the three values. We have A equals to minus 2 over 9. We have B equals to 2 over 9. And we have C equals to 1 over 3, correct? With these values substituted there, we know our partial fraction, correct? So we could write this fraction x minus 1 over x plus 1 times x minus 2 whole square equals to A is minus 2 over 9, so write 2 over here, and 9 times x plus 1. B is positive 2 over 9, so 2 over positive 9 times x minus 2. And C is 1 over 3, so we get plus 1 over 3 times x minus 2 whole square. Is that clear to you? So when there are repeated linear factors, then that is how we will do it. So I hope the steps are absolutely clear. Now let's take up other examples where the degree of numerator is higher. Example number 5, x cubed plus x over x squared minus 1. The degree of numerator is 1 higher. So we could divide, right? So let's divide the numerator by the denominator. Numerator is x cubed. Since x squared is missing, we'll write 0x squared plus x. And we have to divide by x squared. And here also x is missing. We'll write 0x minus 1. So first factor here will be x. And dividing, we get x cubed plus 0x squared minus x. And when you take away, you get 2x. Correct? So we get x plus 2x. So I could write x cubed plus x over x squared minus 1 as equal to x plus, because that is positive, 2x over x squared minus 1. Clear? Now here x squared minus 1 can be factored. So what we get here is x plus 2x over x minus 1 times x plus 1. So again, this could be written as a partial fractions. We could decompose this. We get x plus a. Both are linear, so a constant will be there in the numerator, minus 1 plus b x plus 1. Clear? So the process will be exactly same as we did. The only difference here is, since the numerator had a higher degree, we divided and we got one whole polynomial here without, over the denominator of 1, you can say, right? So now let us try to figure out what is the value of a and b, right? So on the left side, what do we have? On the left side, we have x cubed plus x over x squared minus 1, right? Now, if I multiply by x plus 1 and x minus 1, we do get x squared minus 1. And we have to compare this portion with 2x, right? So 2x is the value which we are looking to compare with. So basically we are looking to compare this portion. Is that clear? Right. Because x is equal to x, so 2x. Okay. So what we get here is 2x is equal to a times x plus 1 plus b times x minus 1. So 2x is equal to, as far as the x coefficient is concerned, we get a plus b, and the constant here is a minus b, correct? So that is the constant. Comparing the coefficients, we get a plus b equals to 2 and a minus b equals to 0, correct? That's what we get. Now if you add them, so these are your two equations, equation 1 and equation 2. So if I add equation 1 and 2, in that case I get 2a equals to 2, or a is equal to 1, correct? If I subtract, right, if I do 1 minus 2, in that case a and a cancel and we get 2b equals to 2 minus 0 is 2. So we get b also equals to 1, right? So we get both a and b as 1. And therefore, we could write our fraction, I should say the polynomial rational function. So now we can write our rational function x cubed minus 1 over x squared minus 1 as equal to x squared plus x, x cubed plus x over x squared minus 1 as x, a value is 1, plus 1 over x minus 1 plus 1 over x plus 1. Is that clear to you? So that is how you can do partial fractions decomposition for this particular function, which has linear factors. However, degree of numerator is 1 higher. So here is the last example. I would like you to pause the video, answer this question, and then look into my suggestions. As you see here, the numerator is of degree 3 and the polynomial in the denominator is degree 2. So we could divide and simplify it first, right? So we could also write this as x cubed over, expanding this we get x squared plus 2x plus 1. That helps us to divide, correct? So let's divide and write this in simpler form. So we have here x cubed, which we could write as plus 0x squared plus 0x plus 0, right? And we are dividing by, let me use a different ink here, x squared plus 2x plus 1. So it goes x times, we get x cubed plus 2x squared plus x. And when you take away, you get minus 2x squared minus x. Bring down 0, right? Okay. So you could now multiply by minus 2, right? So we get minus 2x squared minus 2 times 2 is 4 and minus 2, right? And when you take away, you get plus 3x, and that becomes plus 2, right? So that is what you get. And therefore, you could write this rational function as x minus 2. And here we have 3x plus 2. So plus 3x plus 2 divided by x plus 1 whole square. Is that step clear? So that is the first step. Now we'll follow a similar method as we did earlier. So we are going to write this as x minus 2 plus a over x plus 1 plus b over x plus 1 whole square, right? Now we need to find what a and b are. So let's cross multiply. Well, x plus 1 is our denominator. So we get a times x plus 1 plus b. That should be equal to 3x plus 2, right? So I hope this part is clear. So we are just comparing, because we know x minus, we are comparing these parts. Is that clear? So that is how we are going to solve it further. Now clearly from here, the x coefficient is only a. So we have ax, let's rewrite, plus a plus b equals to 3x plus 2. So from here we get a is equals to 3 and a plus b equals to 2. Substituting 3 here, we know 3 plus b is 2, and that gives us b as equals to 2 minus 3, which is minus 1. And therefore we can now write down the result, right? Since we know what a and b is. So we have this answer, which is x cubed over x plus 1 whole square will be equal to x minus 2. A is 3 for us, plus 3 over x plus 1, and b is minus 1. So minus 1 over x plus 1 whole square. Is that clear? So that is how we are going to get this result. So with this we complete decomposition of rational functions where only linear factors were there. In the next video, we'll take up quadratic factors, repeated quadratic factors, and the condition where the numerator degree is higher. I hope that helps. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.